Before we get to the featured case study on dry gas seal hang-up and centrifugal compressors, let's start with a short introduction. Mechademy provides a predictive analytics solution powered by leveraging physics and machine learning. We utilize these techniques or algorithms to do early diagnostics and identify emerging issues with your rotating equipment. Work started on the solution we call Turbomechanica in 2019, and we went live in mid-2020 with Cove Point LNG as our first customer. Our case study today looks at a centrifugal compressor operating in hydrocarbon service. It has tandem dry gas seals with nitrogen secondary and tertiary gas. The challenge: dry gas seal hang-up tends to occur during transient operations such as a machine start or when there is a sudden change in the compressor's axial shaft position. When a primary dry gas seal is hung up, the compressor primary vent sees higher pressure and flow. However, the overall increase in pressure or flow can be well below alarm and trip levels and can also be caused by other factors such as a change in seal gas supply pressure, nitrogen supply pressure, and/or flare pressure. The approach: Mechademy used multivariate machine learning models trained on the machine's historical data to predict drive-end DE and non-drive-end NDE primary vent orifice differential pressures. We also used expressions to monitor the difference in differential pressure and flow rates in the DE and NDE primary vents, as well as a change point detection algorithm to detect compressor shaft axial movement. Using a combination of the above in a diagnostic algorithm, it is possible to detect dry gas seal hang-up and differentiate the diagnosis from other events, such as a change in primary vent differential pressure due to changes in the flare gas line, or a change in axial shaft position due to sudden opening of an anti-surge valve. Mechademy's Turbomechanica platform detected primary dry gas seal hang-up on the centrifugal compressors several months before a potential DGS failure. Post-detection, the dry gas seals were scheduled for replacement and a planned outage 6 months from the first event detection. Additional monitoring was implemented to trend the seal condition for worsening signs of hang-up. The compressor made it to the planned outage successfully. The seal cartridge was replaced and sent for inspection to the OEM, and as expected, lube oil contamination was confirmed when the seal was disassembled. Primary DGS hang-up detected at least 6 to 9 months prior to a potential seal failure. An unplanned seal failure on the non-redundant centrifugal compressor would have resulted in a minimum 14-day outage due to the need for isolating and purging the hydrocarbon circuit and replacing the seal gas cartridge. This outage would have resulted in several $1 million of lost production. Single rule metrics for primary vent differential pressure, or axial shaft position, are not able to differentiate between process transients and actual seal gas hang-up. Flow meters on the primary vents are notorious for being unreliable. The Turbomechanica platform is the only platform that can integrate data from different model types, such as process, machine learning, thresholding, and statistics, and diagnostic algorithms. For this use case, the ML models predict primary vent differential pressure and provide confidence in the diagnostics. The integrated approach significantly reduces false positives that may occur due to process transients at the facility if single rule metrics were to be used. Thank you for your time and interest in learning more about Mechademy. Please feel free to reach out to us with any questions or comments. Contact our team at Mechademy today to learn more about Turbomechanica. Together, we can enhance your operational efficiency and lead the way in industrial innovation.